Yo, what's up, fam? Today we're going to talk about multiplying fractions and also about how to multiply fractions like mixed numbers and that kind of thing. We're not going to go into negatives today, just the fractions bit. Whole idea is that what are we going to need to do to multiply mixed numbers? Sorry about spelling error. To multiply them. I can go ahead and just fix that right now. That's a typo. It is linked to it's LE South Carolina Standard 7 NS2. So let's write that down. Anyway, so the steps for multiplying fractions go like this. First, you multiply the numerators. Standard stuff. We know how to multiply across. Multiply the denominators. And then simplify accordingly. So number one, if you're taking notes on this, write this one down. It's a good idea. For 2/3 times 1/4, that would be 2 times 1 is 2. 3 times 4 going across is 12. We do want to simplify, so we divide those both by 2. And we get 1/6. Sorry about the thick handwriting. I don't have a pen stylus for this computer. Now we're doing second idea. 1/8 times 2/3. 1 times 2 is 2. 8 times 3 is 24. We again divide those both by 2. We get 1 and 12. So 1/12 being our final answer. Multiplying fractions across is pretty simple. Now when we're doing multiplying fractions by whole numbers, we're going to want to take that whole number, make it into its fraction version, which is just putting it over 1. So for 1/6 times 3, we keep the 1/6. That's still 1/6. Nothing has changed, but we just take 3 and turn it into 3 over 1. 3 wholes, 3 ones. Okay. Then we multiply across normally, same steps as before. 3 times 1 is 3. 6 times 1 is 6. Divide those both by 3. We get 1/2. 1/6 of 3 is 1/2. Same thing for number 2. We get 5 times 3/5. We do 5 into 5 over 1. We do 3/5. And multiply across. I'm going to do 2 different versions here. If you like the second version, it only works sometimes. Depends on what the numbers are. First version, we got 3 times 5 is 15. 1 times 5 is 5. Now we know that 15 divided by 5 is 3. We can divide them both by 5 if we really want to and get 3 over 1, which is 3 wholes. That's version A. Version B looks like this. 5 over 1 times 3/5. Same starting problem. I'm just going to change colors really quick so you can see what I'm doing here. When we have a number on the top and a number on the bottom, that can be divided by the same thing. We can do a little canceling action, which means, okay, we're going to essentially be multiplying by this number anyway, and we're going to simplify anyway. We might as well do it before we start. It might save us a little bit of time. This only works if you have a number on the top and bottom that can be divided by the same thing. In this one, we have both 5 on the top and 5 on the bottom. So I'm going to go ahead and divide 5 by 5 and get 1. I'm also going to divide this 5 by 5 and get 1. Well, as I did it to the top, I must do it to the bottom. Now I multiply across. 1 times 3 is 3. 1 times 1 is 1. We get 3 wholes. Different steps to get the same answer. It might be a good idea sometimes to do that second version. Okay. Next, we've got multiplying mixed numbers. Okay, this is where a lot of people trip up because they think the systems that worked for the regular fractions should work for this one, and they're sorely mistaken. The first thing we got to do is change the mixed numbers to fractions, meaning change them to improper fractions. Then we multiply across, etc. So we have 3 1/3 times 2 1/4. I'm going to do that one down here so you have more room. You can do it on your paper how you need to. 3 1/3, I'll just rewrite it here, times 2 1/4. First thing I'm going to do is change 3 1/3 to its improper version, which means I'm doing 3 times 3 plus that 1. 3 times 3 is 9, plus 1 is 10. The 3 stays the same. 2 1/4, same thing, do 2 times 4 is 8, plus that 1 is 9/4. Now they're in improper mode. I can multiply across. This would be a moment for that second option, so I'll do version A, and then I'll do version B over it. So 10 times 9 is 90, 3 times 4 is 12. Big numbers, I can divide those by 3. I just happen to know that. There's a way to avoid it, you'll see. Divide them both by 3, I get 30 and 4. Oh, what'd you know? There's a bigger number. I could have divided it by 6 the whole time. Oh, darn. My brain didn't go there. Divide these both by 2. You can divide them by 2 and get 15 over 2. You can either leave it in its improper form. This is perfectly fine. or convert it back to its mixed number, which would be 7 1/2. Either of these are good answers. There's no problem with either one of them. I'm okay with improper. Now let's say you did want to do that little top and bottom cross-canceling thing to eliminate some of your difficulty. Not the worst idea in the whole world. Here we see that both 9 and 3 can both be divided by 3. So I'm going to go ahead and do that. 9 divided by 3 is 3. 3 divided by 3 is 1. Okay. I also see that 10 and 4 are both even numbers, so I can divide them both by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. Multiply across, I get 15 over 2. Look at that. Same answer as the one in blue. This also equals 7 1/2, no matter how I spin it. Not too bad, right? So key reminders, when you're multiplying mixed numbers, you have to turn them into their improper versions. Don't be multiplying this original problem 3 times 2. Don't be doing that. That's going to get you lost. It's going to get you a wrong answer. If you would somehow have gone from that 6 and 1/12, you would have just been wrong. It's the wrong answer. That is not how you do these. You have to turn them into improper fractions. Okay. Second problem on that sheet right there, we have 4 3/4 times 2 2/3. I'll do that here. 4 3/4 times 2 2/3. Again, first step needs to be going improper. Notice I'm not multiplying across yet. Those whole numbers are blocking the way. So 4 times 4 is 16. Plus 3 is 19/4. 2 times 3 here is 6. Plus 2 is 8/3. This is a wonderful time for that cross cancel. I'll do both methods again just so you have them both. Option 1, sorry, I'll make a little more room. Option 1 is going to be up here. 19 times 8, ooh, not a good number, don't love that. Got to do some side math. 19 times 8, 9 times 8 is 72. And 8 times 1 is 8, plus 7 is 15. 152 over 4 times 3 is 12. Yeah, don't love how big those numbers are. This would have been a great time to do some of that cross-canceling action. Really, really, really good idea. But we'll hold that for now. We're going to divide both of these by 4. That should work. I know that because math brain, because I know 152 can be divided by 4. So divide this by 4, you should get 3. 152 divided by 4, don't want to make a mistake, so let's just do it out. That's going to be 3. That's 12, 32. So I should get 38 over 3 as a final answer, which could also be, that would be 12 2/3. Those are option A, option B. Let's say you wanted to do some cross-canceling. Man, wouldn't that be sweet if some of this got easier? I'm going to divide both 4 and 8 both by 4. The biggest number I can go into both. That's the greatest common factor of 4 and 8. 4 divided by 4 is 1. 8 divided by 4 is 2. Man, that makes my life easier. Those numbers are so much smaller. 19 times 2 is 38. 1 times 3 is 3. Wouldn't you know it? Man, that's the same answer as doing all that extra work. So, summary. Multiply across. If they're mixed numbers, turn them into improper fractions before you multiply across. When you're going to multiply, you can do a little cross-cancel simplification action to get a smaller number. It might be a good idea. If you have any questions, leave them in the comments, or just find me in class. Laters.